Hi, Earth Science. This is Miss Color going over the 2.6 Global Climate Change admin slip. Okay, so on the front, as normal, you've got the state curriculum, everything that you have to know for this objective. Okay, so make sure you read over that. Okay, and the first thing we talk about is the major climate categories. Now, I've given you the Köppen climate change table that you need to have, and if you don't have a printer, if you'll just copy it down so you have that, okay? But it talks about temperate, tropical, and polar, and then we have to compare weather and climate, which we're going to do down here, okay? All right, so the Köppen climate classification system is the most widely used system for classifying the world's climate. Its categories are based on the annual and monthly averages of temperature. And precipitation. Okay. All right, the Köppen system recognizes 5 major climates. Okay, climate types. Okay, each type is designated by a capital letter, and so you'll need to look at your chart for that. So what type of climates have all month have average temperatures above 18 degrees Celsius, and that would be the tropical moist climates. Okay, and what climates would have deficient precipitation during most of the year, and that's obviously just going to be dry. Okay, and mid-latitude climates with mild winters. You remember latitude and longitude, I hope. Okay, so that's going to be moist. Moist mid-latitude climates with cold winters. And polar climates with extremely cold winters and summers. Okay, so those are the main parts of the Köppen climate classification system. Down here, we're just going to do weather versus climate. And I know you've heard this all before. So weather would be atmospheric conditions over a short time. Okay, so that makes this one atmospheric, we'll call it behavior on this side, over long periods of time. Okay. So weather, we would say, would be day to day. And over here, this would be averages that we would do to figure out the climate. For weather, we talk about temperature, air pressure, fog, humidity, wind, and precipitation. Okay, and over here, we're going to put, since we're doing averages here, this one is more predictable, the climate is, because of the averages, and we can average it over time. And its climate is affected by the angle of the sun and the amount of cloud cover. All right, so how are they the same? That's what goes in here. So how are they the same? Okay, technically they are measured the same way with the same types of instruments. Okay. And we've got temperature, humidity, and precipitation. Those are the main ones. Temperature, humidity, and precipitation. Those are the main ones that we would see that are in common between measuring weather and climate. Okay. So now we have summarizing natural processes that can and have affected the global climate, particularly the El Nino and the La Nina, which we'll talk about. Volcanic eruptions, sunspots, shifts in the Earth's orbit, and carbon dioxide fluctuations. Okay, so when we talk about El Nino, that's normally about every 2 to 7 years. Okay, and both of these come from the Pacific side, so from the west. Okay, and La Nina comes at most definitely irregular intervals. You can't, it's very difficult to predict. Okay, so most of the time this is in December, and it increases the temperature. Okay, it disrupts it. It's just disrupts normal weather. Put it that way. Okay, and it leads to a drought or intense storms. I'm running out of room here, sorry. Okay, so the La Nina, they're supposedly like brother and sister. So it temperature goes down. Okay, it still also disrupts normal weather, or they wouldn't have a name for it. Okay. But the good thing about this one is that it is less damaging than the brother, La Nina. Okay. All right. And I did give you an informational paper about those that you definitely need to read and review. Okay. Get some more background information on those. All right, volcanic eruptions. And the thing about volcanic eruptions, yes, they can affect our climate, and they can also cool it down. Okay, and they can cool because they are shading. They like the smoke and the ash comes up and is shading the incoming solar radiation. But over time, the main concern is increased carbon dioxide. Okay, sunspots. They technically are the cooler zones on the sun's surfaces. Okay, and it's about a third cooler. It's about a third cooler. They're kind of debatable with some people still, but they think that they are protected by magnetic fields. It's kind of interesting. So I suggest you, if you have time, look those up because they are pretty interesting. So these will lead to an increase in UV rays, and they reduce energy distributed to the earth. Okay, and they can have, because of that, they can have a cooling effect. Okay. All right, Earth's orbit. Who would have thought? Okay, so the Earth's orbit, so we're talking about orbital phases over long periods of time. The phases that occur over tens of thousands of years. And we mentioned this at the beginning of our class when we talked about astronomy. Okay, so what they can do, that's definitely long term, okay? The northern hemisphere, I'm going to abbreviate, the northern hemisphere has more land on it. And so land warms faster, and we've talked about this before, warms faster than the oceans. So that will have an effect on that. So you are definitely going to be warmer, okay? And because there's going to end up being more solar radiation because of the change in the orbit. Okay, carbon dioxide fluctuations, okay? Just remember, carbon dioxide absorbs heat, okay? And carbon dioxide stays a long time in our atmosphere is the problem, okay? All right, so this one, carbon dioxide is responsible for about 2/3 of total energy. The energy imbalance causing the temperature to rise. And I'll talk more about that in just a minute. All right, so let's talk about the greenhouse effect, okay? This is a natural thing. This is a natural, what we call phenomenon. Okay, so this is natural. We need this. So it is not the same as global climate change. We need this, okay? So what happens is we have incoming solar energy, okay? And these are the greenhouse gases, okay? And so some of them escape as heat to space. Okay, and most heat is contained in the atmosphere. Okay, so without this greenhouse effect, Earth would be frozen. Okay, so just remember this is a natural phenomenon. So the gases, what they do is that they absorb heat and release it gradually over time. And carbon dioxide absorbs less heat per molecule than others. And we have, and that's the thing, it's more abundant. And that is our problem, is that how much carbon dioxide we're producing, it absorbs less heat, and so we're keeping that heat in. And that is what's causing the global climate change. Okay? Greenhouse gases, okay? One of the main ones is water vapor, which we don't normally think about as being a gas. Okay, ozone, which if we know oxygen is O2, ozone is O3. Carbon dioxide, okay, methane, and actually nitrous oxide. Sounds strange, but it is greenhouse gas. Okay, but why CO2? Why is CO2 such a problem? And that is, of course, because of our fossil fuel use. It's too much. But what's happening right now with everybody, or almost everybody, staying home is that we're seeing a lot of environmental changes that are good for the planet while everybody's staying home. So we'll see how long that lasts when everybody gets back to work. All right, so in this part, we're going to talk about deforestation, okay? Deforestation is a big problem, and that's, of course, when we're taking away large pieces. I did not mean to put deforestation right there. Okay, that should be industrialization, sorry. This is a cause and effect relationship right here, okay? So we needed industrialization first, okay? And this is just the manufacture of goods, different things, how we manufacture things that we need. Now, this one should say deforestation. Okay. And this is major forest to further on our industry. And this is happening too much, and we're killing our forests. And so it's not necessarily a lack of oxygen that we're concerned about, it's the increase in carbon dioxide, because the majority of our oxygen comes from phytoplankton in the ocean. So it's really the trees not having as many trees to take carbon dioxide out of the air is the problem. So this says global climate change. I'm sorry, it's written in white because this was supposed to be color. So less trees means more carbon dioxide, which absorbs heat. Okay. And then we have urban heat islands, which I'm pretty sure we talked about before. You see the city here. It's enclosed in kind of this little thing here to show you. Little vegetation or evaporation causes cities to remain warmer than the surrounding countryside. And I hope that makes sense. Cities have a lot of pavement that holds heat, a lot of buildings, and so not having that vegetation and not really having evaporation from that causes cities to be warmer. So they're called heat islands. Okay. And so regional changes in climate. So we're also using more electricity for air conditioning. It's compounding. Cities will require more electricity. More electricity because more air conditioning. That is one effect. That's not the only effect, but that is an effect. Okay. All right. Actions taken on a large scale to combat global climate change. So banning CFCs, and I think I've talked about them before, but they are chlorofluorocarbons, and you find them in aerosols, and they were banned, and I apologize. In the 80s, I had big hair, and I am part of the reason why CFCs are banned now, because I probably used so much hairspray that I produced part of the hole in the ozone layer, so sorry for that. We are using more sustainable transportation. There is, and you can do this for extra credit, you can email me this for extra credit. There's a city in South America that has probably the most innovative city transportation, public transportation. So you find that out and email it to me for extra credit, okay? Emission standards. What are cars and other vehicles allowed to emit? And that's why we have more like hybrids and things like that. Okay, and then we have passed something called the Clean Air Act. And you can look that one up since I'm running out of time here. Small scale, what we can do on a small scale is we can help to save energy. Okay, we can replant trees. And what city in North Carolina has the most replanted replanted trees per square mile? That's extra credit too. Email it to me. There's a city in North Carolina that's been awarded some award for having replanted. Now they're a big city. They have taken down a lot of trees for lots of buildings and industry and whatnot, but they have replanted trees everywhere they can think of, and so they've replanted more per square mile than any other city in North Carolina. So look that up for extra credit. Okay. And of course we know the recycle, reuse, reduce. Okay, and we can use sustainable transportation too. We can take the bus, which they have in local cities gotten better. And we can carpool. There's other things we can do. All right. So how does this affect the biosphere? Okay. So the biosphere are all the spheres that we have together. So changes in global temps from fossil fuels, deforestation, and agriculture. Okay, and that leads to an increase in sea level because the warmth is melting the ice caps and glaciers, and so that increases our sea level. Okay, we're having extinction of species, and we're having a problem with habitat loss and reduced availability of water. This is huge to remember, okay? All right, so you had a bonus question on the last test about what is ocean acidification, okay? All right, so, and many of you got it. When CO2 is absorbed by seawater, these chemical reactions happen and they reduce the pH. Okay, and when you reduce the pH, if you remember the pH scale, you take it down to an acidic level. So the pH scale is like 0 to 14, 7 being neutral. Okay, and so you have acids here and bases here. Okay, so it's becoming more acidic if you drop the pH down. What causes it? Increased carbon dioxide to be absorbed. How does it affect ocean life? So what happens is that there's an undersaturation with minerals. The minerals don't get absorbed as much because of the CO2, and these minerals are needed to produce and maintain many shells of living things in the ocean. Does it affect global climate change, and if so, how? Okay, it leaves more carbon dioxide in the air because it can't really absorb as much, and so it leaves more in the air, which is increasing the heat in the air. Okay, and so what's happening is that you're seeing this increase in carbon dioxide here, which is lowering the pH, okay? This is carbonate, okay? And many of you put that on your last test, so good job, okay? So it increases the hydrogen ions, which is meaning that's acids. That's what acids do, is increase hydrogen ions right there. Okay, so the carbon dioxide turned into carbonic acid with water, which is decreasing the carbonate, which is needed for the shells. Okay. All right, sea level impacts. Since the Industrial Revolution, we've probably seen, I think it's about a 30% more acidic, okay? Since the Industrial Revolution, which changed everything. So really we have issues. We have lots of issues corroding the surface waters, the less seashells. All of those things are sea level impacts. And then I wanted to talk about the Great Barrier Reef really quickly. So what's happening is that it's bleaching rapidly. Now I hear during our pandemic that it is getting a little bit healthier. And it's doing this due to climate change, obviously, and ocean acidification. Only 7%, last time I checked, was unaffected. Last time I checked. It might have changed by now. Okay? Which is really sad because we need that reef. Okay? All right, that was your climate change admit slip. Please let me know if you have any questions.